Differential equations, type 1, first order, 2011 10a. So here we're given our equation x squared dy dx minus xy equals 7y. And we're told that when x is equal to 1, y is equal to 1. And we have to find the value of y when x is equal to 2. So again, we want to separate out our x's and our y's here. So we're going to try and get dy and all the y's on the left and x and all the dx's on the right. So first thing we have to note here is I'm going to get the dy dx on the left, bring everything else to the right. So we have plus xy. So we want to try and separate out the y and the x's here. So we're going to take out y as being common on the right hand side there. And if I take out y as being common, I'm left with 7 plus x. And then I can divide across by y and multiply across by dx and divide across by x squared. So in other words, I end up with 1 over y times dy is equal to 7 plus x over x squared, and that's times dx. Now, if I go to integrate this, I need my limits. So I look at what do I know at the start and what do I know at the end. In other words, what are my lower limits going to be and what are my upper limits going to be. So at the start, I know that x is equal to 1 and y is equal to 1. And at the end, x is equal to 2 and y is what I'm looking for. So of course, if I want to integrate the left-hand side, I'll be integrating with respect to y. So my y limits, well, my upper limit is the end limits here, which is y. And my lower limits are my start limits there, which is 1. And on the right-hand side, I'm looking at that going, I can't integrate that, so I'm going to separate that out into two parts. So I'm going to write that as 7 over x squared plus x over x squared. And then I'm going to have to simplify that before I can integrate. But my limits then for x, well, my upper limits are the end limits, which is 2, and my lower limits are the start limits, which is 1. So let's tidy that up before we go ahead and integrate. Well, 7 over x squared is going to have to be written as 7x to the power of minus 2. And x over x squared is 1 over x. And I'll be integrating with respect to dx then. Okay, so let's go on to the next page then and integrate that. So if I integrate, well, I have 1 over y integrated is natural log of y. And again, if you can't remember that, you should be spotting your functions, which is page 26 on your maths tables. So you'll see on your maths tables there, 1 over x, when you integrate, is natural log of x, okay? And then that's within the limits of y and 1. And then that equals, well, if I integrate 7x to the minus 2, well, I add 1 to the new power. So add 1 to the power, I should say. So it's 7x to the minus 1 and divide by that new power, which is minus 1. And then if I go back and I integrate 1 over x, well, that's going to be natural log of x. And that's within the limits of 2 and 1. So in other words, I have natural log of y to the power of y, or limit of y, I should say, 1. And that's going to be minus 7 over x plus natural log of x, 2 and 1. Okay, so now it's a bit easier to sub in our limits. So remember, when you're subbing in your upper limit, it's then minus your lower limit. So minus 7 over 2 plus natural log of 2, all in brackets, minus 7 over 1 plus natural log of 1. Now, natural log of 1 we know is 0. If you can't remember that, your calculator will tell you that. And then that leaves us with natural log of y on the left is equal to minus 7 over 2 plus natural log of 2 plus 7, and then natural log of 1 is 0. So therefore that's natural log of y is equal to natural log of 2, and then 7 minus 7 over 2 gives us, which is just plus 7 over 2. And then that's natural log of y is equal to, so if I put all of the right hand side there into my calculator, I end up with 4.1931. And of course, remember that natural log of y can also be written as log of y to the base e. So therefore, if that's written as log y to the base e equals 4.1931, then I can change from my log form back to my index form, which then gives me y is equal to e to the power of 4.1931. And if I put that into my calculator, then that gives me 66.23. Okay, so again, if you can't remember your log indice rules, you'll need to go back to your maths tables, which is page 21, top right hand corner there. Okay, so always going to be important for being able to go from logs back to exponentials in your differential order equations. So again, if we break down the marks, this was a 20 mark question. And we were getting 5 for setting up our equation, and 5 then for integrating. So 5 for integrating, and that's for both sides. And then for subbing in our limits. Sorry, I've after given too many marks up there. Let me just go back there. So 5 for integrating, and then 5 for getting our limits subbed in, and then 5 for the answers. So that's 5, 10, 15, and 20. Yeah, okay.